Hi, good morning, good afternoon, good evening, everyone. Welcome to our Tech Talk on offshore power enable the power of the wind. Before we get started, just a little housekeeping and on how you participate today's event. And we have taken a screenshot of example how your attendee interface looks like. And you have the opportunity to submit a text question to the presenter by typing your question into this Q&A or chat box at any time during this presentation. And this presentation will take a maximum 45 minutes, and we will collect your question and address to the presenter at the Q&A session. Just a reminder to all of you, and you are in mute model. And today's presentation has been recorded, so we will provide to you in next couple of days. So now I would like to inform you the information in this document is subject to change without any notice or should not be constrained as a commitment by ABB Enable. And ABB Enable assumes no responsibilities for any errors that may appear in this document. And ABB Enable reserve all the copyright. So let me make an introduction to our two presenters. And first, I would like to introduce Mr. Lars Henrik Hosel. He is the head of business development and sales for Offshore Wind Able. And another one is my dear colleague Martin Schell Olsen, and he's vice president and the offshore power leader and energy industry in ABB. And I am your host. I am Rita Weifu. And for today's session, we will sharing the experience of going from oil and gas to offshore wind. And we will talk about the key aspect on when commercialize floating wind. We will also discuss how to simplification and scale bring the industrializing to the offshore wind. And of course, we will also talk about how we integrate renewable power to offshore oil and gas asset. At the end, we will have a Q&A session. Before I hand over to Lars Henrik, I would like to remind you, safety is our first priority. Even though I think now during this pandemic period that some of you are listening from home office, and please familiar with your surroundings, and please always obey your local safety rules. And this applies especially when attending this tech talk when you drive in the car. So also, please obey the local corona rules and always keep social distance if that applies to you. So without any further delay, I would like to hand over to Lars Henrik. Lars, I hand over to you.
Thank you, Rita, and thank you for the introduction. I trust that you can see my slides now, see my presentation. If not, please let me know.
And it's in a note model. Maybe you need to change your screen.
Then we give it a second go here on my end, and hopefully you can see it now.
We can see it now. Thank you, Lars.
Very good. First, before we go into the topics of today's discussion and explaining a little bit about our experiences when going from oil and gas to offshore wind, I would like to give a short introduction to Able. For those of you who are not that familiar with us, Able is an EPC contractor for offshore platforms, both within the oil and gas and offshore wind industry. In addition, we have a significant portfolio of frame agreements for maintenance and modification works in particular on the Norwegian continental shelf for offshore installations. And we are roughly around 4,000 employees. Many of us are located in Norway, where we have 6 offices. And we also have locations in Thailand and Singapore. In our organization, we have the capability of taking the complete EPC responsibility for a project, and we also have in-house yard capabilities from our 2 yards. One yard in Haugesund on the west coast of Norway, and we also have a yard in Lam Shabang in Thailand. And these yards are being utilized to construct new platform topsides and modules, and also an important contributor in our maintenance and modification portfolio, and we can also provide yard stay services out of our Haugesund yard in Norway. Within offshore wind, ABB on bottom fixed wind are primarily focusing on the transmission side of the projects, meaning the HVDC substation and AC substation scope. In addition to this scope, that we are also targeting on floating wind for the future commercialization of floating wind. We are also looking at the floating substructure for the turbines itself as well. Based on our experience from oil and gas, we are also capable of providing O&M services to the assets that we are delivering within the offshore wind market also. We have decided to show a brief overview of the project that we have in execution today within renewables, both offshore wind and renewable oil and gas projects. From the left-hand side, we currently have 3 projects in execution in UK within HVDC, where we are having the EPC responsibility for the offshore HVDC platforms for the Dogger Bank development by Equinor and SSE, for Dogger Bank A, B, and C, where we will deliver the first platform in 2023, and the other ones from 24 and 25. In Germany, we are also currently executing the Dolphin 5 project for TenneT. This project is being executed in a consortium together with Keppel FELS, and for these projects we will construct both the topside and the substructure in Singapore at Keppel's yard. As you can see on the pictures on the slide, we are having different concepts for the different projects, where we for Dogger Bank are having a more traditional topside jacket solution, and we have decided to go with the gravity-based structure on the Dolphin 5 project. Also, not within offshore wind, but within the ongoing electrification of the Norwegian continental shelf, we are also executing projects in connection with the Johan Sverdrup development, both on Johan Sverdrup Power from Shore Phase 2, and also in connection with the Johan Sverdrup P2 platform, where we are supporting the establishment of electrification of the Johan Sverdrup field and the Utsira height, with the HVDC from shore and the corresponding HVDC module on the P2 platform. When ABB started looking at the offshore wind market, that was around 2009, 2010. We saw that there was a need within this market for the experience and capabilities that we could bring from the oil and gas industry. We see that there are a set of characteristics that we have, and based on our experience within oil and gas, that is valued by our customers within the offshore wind market. And first, I would like to mention the competence that we have in managing complex projects, which is a key in this industry. We are taking a more mature industry within onshore wind to offshore, and executing large complex projects also in a marine environment in challenging conditions is quite important feature to bring into this market. We also, being an EPC from the oil and gas industry, are quite experienced in efficient management of subcontractors, and of course the HSE focus within oil and gas is something that we can bring forward also to offshore wind, where the HSE ambitions and focus are at a similar level as we see in oil and gas. Also, last but not least, the ability to engage in early phase discussions with client and concept developments in order to find optimal, cost optimal solutions for offshore wind development is quite important within this area. But during our 10+ years within offshore wind, we have also seen that there are some differences in this market compared to oil and gas. We are facing a different set of contractual formats and setups, where the contracts are less balanced within offshore wind than what we are seeing in the oil and gas industry under the NTK regime as well. This includes, but not limited to, both the exposure and liabilities, responsibilities for third parties, and also extended warranty periods compared to what we see in oil and gas. Also, it's an emerging market with new technologies, and we see that it has been a learning curve for both the ABEL, the supply chain, and our clients to develop and further mature the offshore wind industry. Since our clients and the developers of offshore wind projects are also in areas where the need of governmental support and to some extent subsidies is present, we also see relatively long development horizons and timelines for the projects, and the duration of the execution of these projects is quite significant. Based on the above and also the setup between the supply chain and the clients, we see to some extent also an increased risk exposure, but that is also seen in connection with the high degree of lump sum contracts that is used in this industry. Now I will shift the focus a little bit to floating wind and the commercialization of floating wind. And before we go into some of the details, I would like to point out that on the left-hand side, we see a typical map that is known in the industry of applicable areas to develop floating wind going forward. But if we are also combining the population on a global scale and the wind resources that we have in the different areas with the water depths, as you can see on the different screenshots on the right-hand side, we see that the potential market for floating wind for the future is significantly larger than what is currently being explored. Being an EPC, we are also very focused on looking at all aspects of a project development. And up until now, we see a lot of projects at the demonstrator and pilot scale. But when looking at commercializing floating wind, we need to have bigger scales and higher capacity levels to investigate. And when we look at the execution of these projects, with particular focus on the construction phase, we have built some cases where we are seeing typically commercial scale floating wind farms of around 500 megawatts, and then the need of having 50 floating VTGs and VTG foundations if we apply a 10 megawatt solution. What we do see in that setup is that is that it will be a high volume of steel production, and we will also see that we are typically talking about 150 to 250 tons of steel, which will be quite challenging to complete within an acceptable time frame from the project is reaching financial close to ambitions on start production. So when looking at the elements that needs to be developed in order to enter a commercial stage for floating wind, I mentioned the fabrication capacity and capability needs in terms of having this relatively high scale production of floating wind turbine foundations. And even though we are looking at much higher volume than what we traditionally do on the substation side, we cannot call it necessarily the same kind of mass production, scale production as we are talking about in, for example, the car industry, where we are producing hundreds of thousands and millions of units compared to the levels that we are seeing within floating wind. Also, we see that we have rapid development within the capacities and turbine sizes for the offshore wind market, and when the levels are increasing, the sizes are also increasing similarly, and the lifting capacity can be a constraint going forward when we are passing levels like 15 megawatt turbines. And also we have elements or challenges that needs to be resolved within the potential for assembly at the key side for these kind of projects and these kind of sizes. Within floating wind, we are also touching upon issues connected to dynamic cables. That is something that needs to be further developed and commercialized to apply for these kind of projects. And the same also goes for innovative mooring and how to optimize and implement cost reduction to the mooring solutions and the anchoring solutions that we are using. And last but not least, when looking at commercial scale floating wind farms, we will also see a future need of floating substations. These are all challenges or elements that are currently in development in the market, but it's equally important to focus on these and resolve these issues going forward in order to support the further development of floating wind as a sustainable industry for the future. When looking at the items above, we also are entering into discussions with if we are going to see an incremental development within floating wind, or if we are going to see more disruptive solutions. Traditionally today, when going to offshore wind, we have seen, for example, that we have used a setup from onshore that has been proven to work in a good manner onshore, and then take that solution offshore with the single turbine solutions that we have today. And currently that is to a large extent being applied for the floating projects as well. But we also do see different actors in the market that are looking at more disruptive solutions with multi-turbine concepts, and it would be very interesting to see going forward in terms of what will be the sustainable solution or type of technology when we are entering into commercial scale floating wind farms. It's also going to be interesting to see how the purchase patterns from the developer side will be going forward within floating wind. Today we have a lot of different concepts being developed and also executed in both pilot and demonstrator scale, and being also positioned for more commercial scale floating wind. But it still remains to be seen in terms of we will have concept competition between the different alternative concepts that we have today, or if we are going to see EPC competitions based on a selected solution from the developer, and where this concept is then being made available for the EPC contractors to bid for. Different clients currently have different thoughts related to this, and that will also play an important role going forward for floating wind. And also coming back to what I mentioned on the execution of floating wind farms and the capacity requirements in order to execute these kind of projects within a certain time frame. We also will have challenges related to whether the EPC contractor will take the necessary investments in the construction capacity and also the construction facilities in order to take on these kind of number of floating wind turbines, or if the developer is going to place the contracts based on the expected investments to come following such a contract award. As I mentioned during the introduction of this slide, we do see a lot of challenges. It's a lot of interesting problems that needs to be further developed and solved. But as I also mentioned when talking about floating wind, we do see a huge potential for this market, and solving these issues step by step will also support us continue the further development of floating wind. That was it from my side, and I will now pass the word over to Martin.
Thank you, Lars Henrik, and you should now be able to see my screen.
Yeah, can see your screen.
Very good. So thank you. And then moving straight into it, Lars Henrik already mentioned a few of the challenges that of the offshore wind or the energy industry in a broad sense are facing as of now. I will not spend a whole lot of time going into it, but just to set the scene here, I will talk about in the coming sections about a few of these. Also a little bit more around the digital transformation and how you can really use that to better utilize your asset and drive the performance. And then secondly, perhaps looking a little bit how the scale of ABB in a global sense can help you as a developer or player in this game, make sure your projects are bankable also when you enter new markets where financing schemes can be a little bit different from the more established and mature markets. We do believe that coming in with that global presence and scale actually can help you also make these projects a little bit more bankable. And then, of course, there are other areas here in terms of challenges that will be addressed as well. Then, more specifically, then, how do we in ABB help you to address some of the challenges that you saw on the previous slide. I talked a little bit already about the scale, but more specifically then, how do we really do it then? Okay, let us divide it in 4 areas. You have the processes and the procedures, or call it methodology, that are applied. Then, of course, the products or the technology that's always plays into this. Also, digital platforms or other type of data systems, etc., play a part. And then last but not least, the people and their skills. I'm very fortunate to have more than 105,000 colleagues with me, spread across more than 100 countries, bringing a lot of capabilities and skill set into this space, and that is a key strength for us, really. Of course, you see examples of some of these areas to the right. Not all of them are relevant to offshore wind or to any given project, but I think overall, bringing this industrial mindset into this market segment could be a key driver for reducing costs and making sure you achieve efficiency in all phases of your developments, from planning to design and into operations. Then talking a little bit more into the specific on the methodologies. Of course, it's not always about document control and all of these things, but also about business model innovation, really. We have, since we really kicked off our own digitalization journey, if you could call it like that, we have come quite far, both in the areas of how projects are designed, built, and not least operated. As an example now, we have increased our digital engagement with customers by more than 60% in only these 5 last years. And we create alliances of various sorts where you really share, we are willing to share more of the risk to get the design right, but I also think working more closer together reduces the risks and increasing the overall value, which then in the end also can be shared to the benefit of all partakers. Then this same type of approach relates to how things are built, but as I said, not least how they are operated. We see, and I will come back to that part, because we saw really, the traditional way of procurement here and operation is more siloed into subsystems, but we see it coming together more and more as integrated system. And of course, cloud connectivity and all of these type of infrastructure assets help in that, but I also think there has been a mind shift, and we see this mind shift also in offshore wind. Then what about then platforms or digitalization, if you wish? Okay, we are not living on isolated islands in any aspect of life. Of course, as ABB, we are exposed to more or less any given industry out there. And to be honest, some industries have come a little bit more far in terms of how digitalized they are than the heavy industries and the energy segment. We would like really much to help our customers to move up this curve to get most out of the connectivity aspects and analytics and so on as you can. In the last decades, there has been some holding back on the part of industrial companies to embrace all of what you see in these areas. It could be for many reasons, one being cost and one being a sensation of high risk and the eagerness to do things as they always were done, etc. Many reasons, but I think now we really have seen all of these things come down, both the cost levels for the digital technologies, also the willingness and the sensation of risk. So now we are at the prime time, really, to help you to move up this ladder. Of course, industrialization is not only about using data in the best possible way. There are also still, to this day, physical processes that can be simplified, of course. I think, and the headline here should really be why ABB, of course. To the right, you see robotics used in the wind industry. Perhaps that is not the first thing you think about, but this is an image showing ABB paint or coating robots coating a turbine blade. And there could be other aspects of offshore wind development that could be automated in the physical sense. I'm thinking now, for example, of port and harbor logistics or crane automation, if you wish, and there are other things to that. Then on the left, and I said it in the beginning a little bit, I mean, ABB is a truly global company when it comes to the floating world, as Lars-Henrik talked about a little bit. We are not really there, right, in terms of floating wind. You have a couple of pilots here and there. It's coming, and it's coming at fast pace, but in terms of assets that are out there and operating in the floating domain, FPSOs is really the largest area there, and ABB is had the largest installed base of electrical and automation and telecom systems for floaters globally. And you can say, okay, what's the similarity between a FPSO and an offshore wind farm? Well, I would say not so much in terms of what is being processed, but a whole lot when it comes to how you actually operate the asset. It tends to be in far away, so you need to have some thinking about how you connect to it in a safe and secure way. You need to think about operations and so on and so forth. So all of these aspects are quite similar, and we have the experience to get that right and help you set yourself up for good projects and good operations in the end. Then, and I will not speak a whole lot about it, but it is worth mentioning what is actually ABB's scope in the offshore wind space. First and foremost, of course, we are there to make your assets safe and secure, make sure you can operate them in a good way in remote places, and really drive towards more lean operations or with less manning or eventually unmanned in the end. And of course, drive down cost of the electricity produced and making sure the uptime is as high as it can be. On the one end, we supply pieces of equipment going into the turbines, being generators and converters and control and protective gear. So we are the world leader, and I think the number says there are 40,000 wind turbines we have supplied to globally. Probably it's a few thousands more now. I don't have the exact figure, but it's in that range, and we are the world leader for the generation and the power conversion side of things. Then, not so logical to think about at first, but we are also supplying systems to the vessels going out at sea, doing any type of operation, being installation of new assets to servicing those that are already there. So we provide very energy sustainable or energy efficient propulsion systems, including battery systems and potential use of alternative sources of fuel such as hydrogen and so on to these vessels, plus connect them to operation centers and give advice so they can operate in the best possible manner. All this together, being present at the turbines, being at the offshore substations and the onshore substations, and in the marine operation side of things, makes us a good partner in the right circumstances to help you have a holistic view across the asset parts of your total wind farm. Then a little bit more in zooming in what we are then as ABB Energy Industries delivering to the offshore substation specifically. And then I'd like just to use an example of a project that we are at the moment executing together with ABEL successfully, I'd say. For this particular project, which is the Dolwin 5 offshore substation in Germany, to be owned by the transmission system operator TenneT, we are delivering more or less all the systems that you need to make the substation a safe and secure place to be, and you can see those systems summarized at the right of this slide. We like to call these systems together as industrial control. You could call it EICT or whatever, but it's mainly all the automation systems that are there, including SCADA, condition monitoring of all of the assets, not only the pieces of equipment that we are delivering ourselves, but all of the equipment pieces out there. Then also we are delivering IT infrastructure, including cybersecurity services on top of that. Plus on the electrical side, of course, you don't see listed the main high voltage electrical equipment on this slide. We are not delivering that to this system, but that said, there are a whole lot of other subsystems and consumers that need power on the asset itself, and we are delivering then the low voltage distribution system powering those plus a UPS in case of you lose the power from the turbines. Then this is an important area really that it sets you up for being being able to benefit from operating your assets remotely with as few human resources as possible, and that is the telecommunication systems. I move to the next slide to show you that these systems they are not only located at the offshore substation itself. You will find them on the turbines or up there in the nacelle. You will, in certain cases, have telecom hub platforms, and then there are telecommunication systems, onshore. And all this if you can seamlessly integrate them, this system in a good way, you are really setting yourself up for the possibility to operate very efficiently. And we'd like to think that we are a very good partner in helping you to do so. Then moving on a little bit on the automation side again. What we see in the offshore wind space is that a wind farm typically, or at least, have 2 or 3 different SCADA systems. You have the wind turbine generator SCADA, or WTG SCADA. Then you have the wind farm owner SCADA. And then in some cases, you have a separate offshore transmission owner SCADA. So this results in the O&M teams, or operational and maintenance teams, having a handful of SCADA systems to attend to, and it's not really consistent when it comes to user interfaces and setting you up for enterprise-wide collaboration in the best possible way. So we propose that that you can put a central SCADA on top of this, and we can be a partner in that, being turbine vendor agnostic and also high voltage electrical system agnostic. And you see some of the benefits that this can unlock if you deploy it this way. At least from the high level, it really empowers the possibility, or it opens up a few more options on how you can drive your operations to a better state, because you get better visibility across these various parts. And then, of course, you can put optimization solutions on top, or other sorts of applications on the data. But to start with, you have to bring it together, and this is one way of doing it. Then we get a lot of questions now. What is ABB's role when it comes to electrical system design and integration? Let me say it like this. It's unchanged. We are a strong entity end-to-end when it comes to performing these type of tasks that you see before you, going from the early phases in concepts, studies and feed, through actual project deliveries to operational maintenance in the electrical domain. With the carve out of our high voltage electrical business to the joint venture between Hitachi and ABB, we are a little bit more free when it comes to from which factories and which suppliers we can source the actual high voltage equipment. But let it be very clear, we can still play a role in this space. We have the capabilities, the skill sets, and the tools to help you to get the electrical system design to a very good level and execute together with you in the projects. One example of a role in such regard is a study we performed for Equinor's Empire Wind project as an early phase study to develop a technical concept for the electrical systems, including design of offshore and onshore, design of onshore substation, plus of course all the systems at the offshore system, not the design of the offshore substation itself, but all the systems that you saw on a previous slide, etc. Now, in the commercial or the execution phase of this project, it might be that the scheme is different, but this is to say that we have the competence to perform this task, and we have the references to prove it. Then the next slide is a little bit exotic, if you like, but we are also really, I mean, ABB throughout its existence for more than 125 years has been an innovator in the electrical space, and we continue to be so. One area is to look at, can you put some of the pieces of equipment that now reside on the top side of your substation on the seabed? We believe you can. For example, you can have the transformer there connected to a range of array cables on the secondary side, and then stepping it up to the relevant export voltage level, and there you go. Of course, there are some a few technologies that has to be matured further, but the transformer, the subsea transformer by itself, which is really at the core, is a proven solution. We have delivered more than 35 of subsea transformers, although it should be said at lower power ratings. Even so, we have done some tests and our own investigations, and we are ready to engage for sizes, as you see denoted on the slide, at around 300 MVA at the moment, making it, in our view, an attractive concept to consider for upcoming floating offshore wind developments. Then my last topic, and I see we are coming closer to the Q&A session, so I will try to speed it up a little bit at the end, but it's the topic of how can you integrate renewable power to oil and gas assets. I mean, Hywind Tampen in Norway is probably known to many of the audience here today. We are part of that project to help Equinor get the scheme right. I mean, Of course, there are some goals to do it. You would first and foremost reduce your emissions, but you have to run your generators less, your gas turbine generators less, in essence. Of course, on a higher level, there are other goals also. You would like to use perhaps oil and gas industry as a platform for driving down the costs of floaters and so on, because of they have a higher implicit energy cost as of today, and there are different tax regimes and so on and so forth. But I will not talk about those aspects. I will talk about a little bit more of how can you really secure your power quality and not distort the process you already have there out at the sea, because you don't want to use it at the test bed and ending up in a situation where you actually cannot produce what you are producing, because then the calculation doesn't look really attractive. Of course, there are some challenges here. Renewable power, both solar and wind, is intermittent by nature, so it varies, right? And that has some effect on the power quality, both on voltage stability and frequency stability. We have a toolbox to look at these things. What we do have is a quite unique tool. We call it Process Power Simulator. We use it in a way where we first create a model of the electrical system using standard building blocks, including typical loads and generation sources and so on. We have in there wind today, gas turbines. We have energy storage or batteries, if you wish. And in the future also it will include fuel cells, both, which can be both and hydrogen electrolysis and so on. So it will be a complete tool to really study in depth the behavior of a process and looking at the electrical system around it. Of course, you can use such a tool to evaluate your concept, mostly when it comes to power management and electrical control. But you can also use it then when it's up and running to train operators in running your new and upgraded assets. And before you come to that stage, it could be used for doing virtual FAT or virtual commissioning and so on and so forth. And this electrical tool, it integrates very well to our process control platform and so on. So it's ready to be used and integrated with the overall control system in the end there. Then some preliminary findings from what we have looked at the Hywind Tampen. And of course, as I said, introducing wind turbines had some effect on the stiffness of the frequency and voltage. Okay, perhaps you need to introduce some new gear or filtering and so on to stiffen the system again. But at least this is something that we can evaluate and help you get right in the end. Then luckily, actually, the CO2 emissions are as good as was thought from the beginning. Now it's not in operations, but our simulations shows that you can save quite a bit on your CO2 emissions, which is in the end both good due to you save some taxes, but more importantly for the environment at large. Lastly, I'd like to say that we are not only looking at simply integrating wind to oil and gas assets at the other end. We strongly believe that if Europe in particular is going to meet its very hefty ambitions with regards to installed offshore wind capacity, you need some other means of carrying all of that energy than high voltage electrons at high voltage level. So you would need hydrogen to carry it, ammonia or something else. We are already now looking at very concrete projects, or call them mature pilots, where such a scheme is being considered and to be built. Important there is not to reinvent the wheel, but rather using the components you already have. You see schematically now the role of ABB in such a project. It's not only powering the electrolyzer and having the electrical gear to integrate the wind power, but also on the overall level, looking at the energy management and process control and so on. And I'd like to end by saying that when it comes to to wind and hydrogen together. We have a very compelling portfolio of products and solutions that's already there. So we could be a key partner as we now see a more mix of energy carriers being introduced to the mix. So with that, I'd like to thank you for listening to my presentation, and then we turn to the last part of this session, which is a Q&A, and I will end there and hand the word back to Rita.
Thank you, Martin, and thank you, Lars, for the great presentation. We have received quite some questions. So first question, I will go to Lars Henrik, and the question is, how does ABB compare and compete with the Ørsted? I think it's a Danish power company, and does ABB have a presence in the US?
Yeah, coming back to the first of your question, Ørsted is a developer of offshore wind project, and ABB are not competing with Ørsted or any other developer of offshore wind, as we are not the developer of these kind of projects, but we are a typical tier 1 contractor to developers of offshore wind projects as such. Lastly, we have a presence, as I mentioned, in Norway and in Southeast Asia, in Thailand and Singapore. So we are not having a presence in the US. However, both in the US and other emerging markets in Asia and elsewhere, we are closely following and supporting the development of offshore wind at a global scale.
Great, thank you, Lars Henrik. Now I have a question for Martin, and the question is, which part of offshore wind farm will be manufactured by ABB?
Okay, so very briefly, I'd say it's two aspects of that. One is all of the equipment and so on that we put into the turbines. That is generators, power conversion, protective gear and switch gears and so on. That is a product game mainly, and we sell these to Vestas, GE, Siemens, Gamesa, and GE, and all of the vendors or manufacturers of the turbines. Then secondly, and this is a little bit more of core of what we do at ABB Energy Industries, and that is the systems that I talked about to the offshore substations, including automation, telecommunication, low voltage distribution, but also the services on top of that to make sure they are safe and operated in the most efficient way.
Thank you, Martin. Then this question actually for both of you is something about how we really have offshore wind and hydrogen production could be potentially be interconnected. So is there something ABB and ABB are interested in and any plan in this area?
Yeah, I can start from the ABB side, and as I mentioned during this presentation here today, obviously offshore wind is a key focus area for us both currently and also going forward. And we are also looking at the developments that we are seeing also in the market when it comes to hydrogen, and of course that could potentially also be combined or an interconnected aspect to work more on going forward and well within in our areas of interest.
Okay.
Yes, I can also comment. Definitely, ABB is interested in the hydrogen space, and as I said at the end of my presentation, if EU or Europe in total is going to achieve its targets of offshore wind, it's in our view quite necessary to look at alternative ways of carrying that energy being produced. Otherwise, you will have high voltage cable, you will have cable spaghetti on the seabed, and you don't want that. So you have to carry it by some other means, and we are looking with that. And of course, we will cooperate with ABL also, and given the right circumstances in that market as well.
Okay, that's good. And there's another question also for both of you. And the question is about, can you two talk about the Doggy Bank project, and what that mean for a company to be involved in this world's largest offshore wind project? And what would a factor that lead of our two companies to secure the Doggy Bank and success?
Yeah, I can also from ABL side. Obviously, we are very happy to participate and deliver to the development of Doggy Bank. For us, it's yeah, a proof of the work that we are doing in this industry, and also gives us additional experiences within the offshore wind market as such. And in terms of the factors that led to the specific contract award, it's difficult to go into too much details in such a session like this. But obviously, we do believe that the offering and the solutions that we provided was something that the client valued, and also, of course, the experiences that we brought into the picture, both from oil and gas and also from offshore wind, played a role.
Yeah, no, I agree, Lars Henrik. I think it's always about listening to what the developer or what the customer tells you, and being agile and adaptive enough to act upon that. And I think both ABL and ABB and many others, of course, can do that well. But at least to us in ABB, start by listening to the challenges that the customer present to you. It could be Doggy Bank, but actually I would answer the question and saying it doesn't really matter which project it is. At least myself, I would like, if you have a challenge, I would like to help you. Simply as that. But of course, it's a proof of our capabilities that Equinor has chosen also ABB to take part in the Doggy Bank development. We are very thankful for that, of course.
Great. Okay. And another question is about subsea, since we are talking. So it's actually two questions about subsea. First one is regarding subsea substation, how it is cost effective with respect to floating or foundation based on offshore substation.
Well, it's a little bit like that, depending how you set up your calculation. But if it's going to be a reality in the future, of course, we realize that it has to be cost efficient. I would say probably on the CapEx side, it could be somewhat more expensive, at least as of now, because it's some more difficulties when it comes to installation and so on. But for operations then, and not least maintenance, the costs are very low in the lifetime view. So altogether, we think it's already now cost efficient compared to an topside substation. But again, this depends on a whole lot of things. It's not the right concept for every project. It can be for certain, but we would like to engage with the customers and start to investigate these things a little bit more into depth. And then I'm sure, given the right circumstances, it could be a good solution.
Super. And then the question actually to Lars, and is also about the, how do you say, the subsea. And yeah, and the question is, the offshore industry is limited to shallow water, and it's possible to look into even go into every deep water, and what can be the challenge for that?
Yeah, no, we do definitely think that we can go into deeper waters for offshore wind going forward in the future as well. Obviously, you will at one point in time meet the threshold for when you need floating wind compared to bottom fixed, but that is probably another discussion. On the challenges that we would face when going into more deeper water, I think that typically one that you will face is how you should optimize the mooring solutions for the projects, because at more deeper water, of course, that will be an expensive contributor to the projects, obviously depending on the water depth we are talking about. But that is also something that the industry is working on in terms of more innovative solutions when it comes to mooring and so on.
Okay, thank you. We are top of our hour, so I would like to ask a last question, and if you both don't mind. And so this question is talk about how are frame agreements used to develop a supply chain in the offshore wind buying process?
No, I can start perhaps. Of course, we are willing to look at frame agreements, or even for supply, but also frame agreement for project alliances. I mean, the earlier we can sketch out these things, the easier it will be to work together once you face real opportunities. So, of course, the short answer is yes, we of course are willing to look at frame agreements.
Yeah, from our side, we also do see that that frame agreements are to some extent being used in the offshore wind industry as it is for both oil and gas as well. But also I think the benefits of frame agreements would also probably also have depend on the scope that you are talking about and so on. In terms of repeat deliveries and the number of units and the number of services that is being provided either from us or from our competitors or suppliers for that sake. But definitely it's something that we are seeing being used in the industry.
Okay, super. We still have quite a lot of questions we are not able to answer now, but we will definitely answer that and to contact each of the people who ask those questions individually. And again, thank you, Lars, Henrik, and Martin, and for your great presentation. And thank you everyone for joining us. Have a nice rest of the day. Bye.